Welcome to Academic Giant. Today's topic will be power factor correction in SE. So, I'll be providing the basics concerning power factor correction. So, the first of all, the one of the most important thing that we must understand is what we call the apparent power. So, the apparent power is represented by the letter S. Its unit is VA. Sometimes it is called complex power. So sometimes, or complex power. But the big question is, why is it called the complex power? Why are we having the name complex power? So we're having the name complex power because S has got the leave part and complex, and the complex part. This leave part give birth to real power, or sometimes called true power. Its unit is watts. Then these complex parts give birth to what we call the reactive power. So the reactive power is represented by the letter Q, and it is useful in inductors and capacitors. Inductors and capacitors. The real power is the power that is consumed in resistors. So let's discuss now the complex power. Or let's discuss the reactive power. So let's start with inductors. So a good example of inductors is what we call a coil of wires. This coil of wires, when subjected to SC current, they produce flux. So since we know current is being used to produce flux, hence we know there are losses that are involved in form of heat. Hence, as such, there will be power will be lagging in an inductor. But when we come to a capacitor, a good example of a capacitor is a battery in our phones. So we know when we subject a battery to our source, it's able to store some charges and able to provide those charges when we are in need of them. So since it is able to produce power, so in a capacitor, power always leads. But we want to put this information on a diagram. And remember, in an inductor, the formula for we want to put this in a diagram. So you have this diagram. This is our real power, this is our reactive power, and this is our complex power. So reactive power can either be negative or positive. So why are we saying negative? Remember, a capacitor does not consume what? Reactive power. Instead, it produces reactive power. So hence, when it is represented mathematically, it is represented to the negatives. While for inductors, since it consumes power, it is presented to the positives. So when we have this triangle below, we say power is what? Power is leading. Why is it leading? Because we know a capacitor produces what? Reactive power. And when we have this diagram, we plot the three powers, and we have this diagram, we say power is what? Lagging. Why are we saying power is lagging? Because an inductor uses the reactive power. So this will be the end of my video. I'll upload a complete video in due time. Please subscribe to my channel.